Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, the GMAT Official Guide 2024. If you do not own this book already, purchase one immediately. You're going to need it. Always make sure that this book is in front of you when we are working together. Today is our lesson number 39. We are on page number 99. On page number 99 you will see 4 problems in the second column that we have not done yet, starting with number 163. Problem 163, as you can see, is already on the blackboard. I'm going to read the problem to you as usual, then I'm going to get out of the frame. I would like you to pause the video, solve the problem yourself, and then we'll compare your work against the work we'll do together. You know the routine. Here we go. So we are told that in a school, the current ratio of students to teachers is 30:1. That's the current ratio. We are further told that if the number of students goes up by 50 and if the number of teachers goes up by 5, we are told that in that case the new ratio becomes 25:1, from 30:1 to 25:1. The question is very straightforward. Question is quite simple. Question simply is, how many teachers do we have currently? Here are the answer choices. I'll give you a second for you to be able to pause and unpause the video. Alright, let's see what we can do, okay? So we're going to use letter S to represent the current number of students. We're going to use letter T to represent the current number of teachers. So once we solve for T, that's what we're looking for. We're looking for how many teachers do we have at present. Let's begin. So the first thing we know is that the current ratio is 25:1. And then we'll deal with this situation in a second. So since S represents the current number of students and T represents the current number of teachers, this is what we have to start out with, 30:1. Let's simplify this thing. So that implies that S has to equal 30T. Because we're going to have to use that in a second. And here's a new situation. We are told that if the number of students goes up by 50, so we have S right now, it goes up by 50, and if the number of teachers goes up by 5, we have T number of teachers right now. If it goes up by 5, we are told in that case the new ratio, I erased it, the new ratio is 25:1. And that's all there is. There are 2 very straightforward simple linear equations and we have to solve for T. Let's begin. Let's cross multiply, so we get S plus 50 equals 25T plus 125. Let's see what we can do next. Let's substitute. We know that S is equal to 30T. We're going to substitute it right here. So 30T plus 50 equals 25T plus 125. Actually, this is even more straightforward than I thought. Subtract 25 from both sides. So we're going to have 5T equals 125 minus 50. That gives us 75, which means the T, that should have said 5, not 2, because we're subtracting 25 from 30, which means 5T equals 75, T is equal to 15. That's all. The answer was E. Let's do the next one, shall we? Quite straightforward, quite simple. We are told that we are looking for the smallest value of integer n, the smallest integer n, such that it satisfies the following condition. 25 raised to n has to be greater than 5 raised to 12. And here are the answer choices: 6, 7, 8, 9, and 10. Those are the answer choices. Again, one more time, pause the video, do it yourself. Let's see what we can do. Well, 25 raised to n can be written as 5 squared times n, which is 5 raised to 2n, and we know that has to be greater than 5 raised to 12. If that's the case, then that in turn implies that 2n has to be more than 12. And that in turn implies that n will have to be more than 6. And since we are looking for smallest integer, the smallest value of n, it has to be more than 6, therefore it has to be 7. Let's do the next one, shall we? 165. These two were quite straightforward. Number 165 will involve a lot of writing on my part. We just have to be patient. We are told that we have a group of people in which 60% of them are women. We are further told that 45% of women are lawyers. 45% of the women in this group happen to be lawyers. Here's the question. If one is selected at random, what are the odds that the person that we're going to select, what are the odds that the person selected is a woman lawyer? What are the odds that the person we're going to select at random out of this group happens to be not only a woman but also a woman lawyer? Here are the answer choices: 10, 15, 27, 33, and 45. And of course they all have percentages next to them. Go ahead, do it yourself. Let's see what we can do, shall we? We need the room, so I'm going to erase everything. Here's how we're going to set it up. So again, in a group, 60% of the women, 60% of them are women, 40% obviously are men. And of the women, 45% happen to be lawyer. What are the odds that the person we're going to select at random happens to be a woman lawyer? So let's make up a number for the number of people in the group, and it always helps to make up some nice number. We're going to make up 100. Let's pretend that we have 100 people in the group. If that's the case, then we know we have 40 male and 60 female. And we are further told that lawyers and non-lawyers. Lawyers are 45%. So this was 60%, lawyers are 45%, which means the odds of finding a person, picking a person at random who happens to be a female lawyer, the odds are 45% of 60%. 45% of 60%, but since we are using 60 as a number, that's what we're looking for. Let's find out what that is, shall we? Divide top and bottom by 10. Divide top and bottom by 5. This becomes 9. This is going to become 2. So it's 9 times 5. Oh, we can do one more time. This 2 can go away. This can. Oh, this is very simple. It's just 27%. The odds are 27%. The odds of finding such a person who happens to be a female and a lawyer is 27%. Let's do the next one. $12.50, $15.63, $2.250, $2.560, and $2.752. Those are the answer choices. Here's the question. This is number 166. We are told that the number of trees in an orchard is x. We are further told that each year the number of trees goes up by 25%. So we have an orchard with given number of trees in it. They don't call it x, obviously, I'm calling it x. We are told that we have an orchard with certain number of trees, and we are further told that each year the number of trees in the orchard is increased by 25%, and that goes on for 4 years. For 4 years. Further, we are told that at the end of 4 years, we have 6,250 trees. Question is very straightforward, very simple. The question simply is, how many trees did we start out with in the orchard, so that at the end of the 4 years, after having planted 25% more trees than what we had the previous year, having done that for 4 years, we will have 6,250 trees. Go ahead, pause the video and do it yourself. Well, let's see what we can do, shall we? Okay, I need the room again, so we can erase all of this thing. Let's set it up. Let's set it up on a timeline, so it's easier to visualize it. Let's set it up on a timeline. So this is the period x. We're starting out with x. At the end of first year, we'll have 1.25x. The following year, we'll have 125% of this amount, which is same as saying 1.25 squared x. The third year is going to be cubed, and the fourth year is going to be 1.25 raised to 4 times x. And this quantity we know has to equal 6,250. All you have to do is solve this number. So solve this equation. One point 1.25 raised to 4 times x equals, I forgot now what it was, 6250. Let's see what we can do here. The key here is to understand that if you were to leave this quantity in the form of a decimal, it will make your life miserable to try to figure out 1.25 raised to 4. Be smart about it. The smart thing here is to convert this decimal into a fraction. Don't deal with decimals. 1.25 is simply 5 over 4. This is 5 over 4 squared, and so on and so forth. This is 5 over 4 raised to 4. And you will see in a second that it will help us a great deal. And that has to equal 6250, which in turn implies that x would have to equal 6250 times 4 raised to 4 over 5 raised to 4. Let's see what we can do. Okay, I'm going to continue on the top. Again, you have to learn to play with the numbers here. Don't leave 6250 as it is sitting. These numbers are given for a reason. There is a reason why they tell us it is 6250 and not 6200 or 6275. That number is a magic number. So that implies that x, we're going to pick it up from here. Let's write this quantity as 625 times 10 times 10 raised to 4 times 4 raised to 4 times 4 raised to 4, which I prefer to write it as 16 squared. Because if I leave it at 4 raised to 4, then I have to do it out in my head what 4 raised to 4 is. 4 times 4 times 4. It's much easier for me to figure out 16 squared. 16 squared is 265. I hope you know your squared 1 through 20. 16 squared is 256. I already know that. And at the bottom we have 5 raised to 4. 5 raised to 4 is simply 25 times 25. This quantity is simply 25 times 25. I hope you are able to see right away that this quantity goes away. And what we're left with is 256 times 10. There you go. Right there. The answer is C. Or rather, answer is D. What letter it is, it does not matter. His answer is 2560. That was the end of that page, page number 99. That was the last question on that page. We'll meet again tomorrow, and we'll tackle the problem that you see on the following page. Okay? Bye now.